Good morning, student. So today we are going to discuss about this. We have to discuss about the indicated power. We have to discuss about the means we are going to study about the performance of IC engine. And for understanding the performance of IC engine, we have to aware about the how we are doing the testing, how we are doing the testing, and why we are doing the testing. If you have to understand the performance of the IC engine, you should aware about the different types of parameters which can give you the performance of the IC engine. So if you are discussing about such a parameter, so what are the main parameters are there? So these are the basic parameters. So you have to understand what is the indicated power, and what is the brake power, what is the frictional power, how the heat energy is balancing of heat energy will be the evolution of the heat, and how we are utilizing that heat in different forms. Again, you have to means you have to give the performance of engine in terms of different efficiencies. Output efficiencies are there, such as brake thermal efficiency, indicated thermal efficiencies, mechanical efficiencies, overall efficiencies, then volumetric efficiencies. If you are considering about the volumetric efficiency, then again you have to understand how the fuel consumption is happening. So there are many parameters are there that you need to understand for analyzing the performance of the IC engine. So for that, many of the parameters are there that you cannot calculate by numerically by calculation. So for getting such parameters, so we have to test the engine. We have to test the engine. So prior discussing about that, so we have to think about what is the objective about of testing. So objective of testing of IC engine is nothing but the we are doing the testing of IC engine to determine the information. What we are doing to for determining information which cannot be obtained by the calculation. Then second one is there, we are doing the testing to verify or confirm the validity of data used in design. So whatever the data we are using in design, so for validation of that data we are using the testing. Then again, for to satisfy the customer regarding the performance of the engine. Then again, to justify the rating of the engine and guarantee the fuel specific fuel consumptions. Again, in order to reduce the overall cost, to increase the power output with subsequent decrease in fuel consumption. So you can link this with the turbocharging that and EGR, so which we have already discussed it in first unit of this power engineering and refrigeration subject. So in first unit we have studied how the EGR is reducing the pollution, and then how that supercharging is increasing the power with reducing the fuel consumption. So these are the some of the objective of testings. Then what are the different methods of testings are there? So there are three types of testing methods are there: commercial method, thermodynamic test, and PUC test. So the majority of tests on IC engine are carried out for commercial purposes. So in commercial test, normally we are calculating, or we are finding out the rated power output with respect to fuel consumption. Again, we need to find out the quantity of cooling water, what are the quantity of lubricating oil we are supplying to the engine, then what is the overload capacity of the engine, and we have to check the exact timing of the valves and injections of the fuel. Again, we have to check the robustness of the engine when engine is running at different loads and at fluctuating loads. So these are the main parameter we are finding out or checking under commercial test. Then in under thermodynamic test, so we are whatever the parameter we have discussed at the initiation of this lecture, so that different basic parameter we are finding out under thermodynamic test, such as indicated power, brake power, frictional power, and for finding out that we are using the different methods. We are using the different experimental methods. With the help of that experimental methods, we are finding out. So we can call that experimental as a method as a thermodynamics test, by which we can find out the indicated power, brake power, frictional power, then indicated mean effective pressure, what is the fuel consumptions, what is the air consumption is there. So whatever the things we have discussed under thermodynamic test, that we are going to discuss in detail in the coming lectures again. So then again, for PUC test, normally we are using the for finding out the concentration or percentage of pollutant. Means what are the exhaust gases are there are pollutants are there, and what is the percentage of pollutant in the exhaust gas, that for that we are using the PUC state. So in that we are finding out the percentage of carbon monoxide, hydrocarbon, and smoke density we are finding in the PUC test. So these are the testing methods of IC engine. So now these are the theoretical part we have discussed. Now we have to understand how we can find out the indicated power, how we can find out what is the indicated power, and what is the brake power, what is the frictional power. So that we have to understand, so we'll see one of the so just refer this diagram. Now here we have you can see the block diagram of IC engine. So already we have discussed the operation of IC engine. So what are the different processes are there for completing the cycle of IC engine. So here if you are thinking about the now, just see, this is the, we can say this is the cylinder. Now here the what we are doing in case of CI engine and in case of SI engine, the process of combustion is happening by different methods, but what is happening over here, we are combusting the fuel. So what we are doing, we are combusting the fuel, and due to the combustion of fuel, there will be the heat will get released here. Whatever the heat will get released, so due to that heat, it will act the pressure on the piston. It will act the pressure on the piston throughout the expansion process. Throughout the expansion process or throughout the cycle, whatever the pressure is acting upon the piston throughout the expansion or throughout the cycle. So if you are hypothetically finding out the average of that pressure, you can say that if you are finding the hypothetical average pressure of that total or different range of pressures, so whatever the hypothetical average we are getting, that average we are calling the mean effective pressure. We are calling is that is the mean effective pressure. So inside the cylinder, when the heat will get generated and due to that pressure will acted, so there will be the power will get produced, and whatever the power will get produced inside the cylinder, that we are calling as the indicated power. That is what we are calling as the indicated power. And whatever the power we are utilizing for commercial purpose, that is the crankshaft. So we are whatever the power we are getting in the crankshaft, and that crankshaft we are supplying to the for different applications. So this is the useful power. So this is the useful power, and this power we are calling as the brake power. Now see, inside the cylinder we will get the power, means due to the heat release from the combustion of the fuel. So that we are calling indicated pressure, and this power will get in the expansion process, and for expansion process this gas will expand and try to put the pressure on the pistons throughout the expansion process. So intensity of pressure will be varied throughout the expansion cycle. So we cannot say that the maximum power at the when the piston is at TDC, and when there is a less of power when the piston is at BDC. So we are taking the mean pressure, and that mean pressure we are calling the mean effective pressure. We are calling as the mean effective pressure, and whatever the power is generated inside the cylinder, that we are calling as the indicated power, and whatever the spool power we are getting at the crankshaft, that we are calling as the brake power, and whatever the losses are there, we are calling that is as a frictional power. That is, we are calling as a frictional power. Means logically, if you are thinking, indicated power will be higher than the brake power, and whatever the losses are there, that we are calling as a frictional power. So in frictional power, there are frictional losses, power lost by the frictional losses. Then again, in unit number 1 we have discussed, there are many components are there, they will operate by the power from the engine itself. So opening and closing of the valve, because opening and closing of the valve will be done by the camshaft, and that camshaft will be driven by the engine power. Again, for so here already we can see here, so there whatever the losses are there, that is losses due to the frictional, losses due to the pumping, and some of the unaccounted losses are there. So if you are deducting them, then we will get the brake power. So now we have to see how we can measure the indicated power. So for measuring the indicated power, we can use motoring test, we can use MOS test, and again we can find out this with the help of indicator diagram. In your thermal engineering, you have discussed about the some simple concept is there. If you have to find out the work done by the cycle, so you are finding that work by using the area of the cycle. So whatever the process means, if cycle is completing with the help of different processes, and area enclosed by that cycle will give you the work per cycle. So now just listen what I am saying. The work done by the cycle we can calculate with the help of PV diagram, and in PV diagram whatever the area enclosed by the cycle will give you the work done by the cycle. So this concept we are using for finding out the indicated power. We can find out the indicated power with the help of this concept. So again we will take one more diagram. So we will take this diagram. So now, so we have plotted the, so this is the cycle for ideal. So this diagram is showing the PV diagram for ideal 4-stroke cycle engine. So there is a 1 to 2 is the compression process, and 2 to 3 is the heat addition process, 3 to 4 is the expansion process, and 4 to 1 is the heat rejection process. So this diagram is indicating the it is indicating the cycle completed by the for ideal 4-stroke engine. So here you can find out here there is a different pressure ranges are there. If you are finding the average pressuring, means if you are, and we can say that the area enclosed by this diagram is nothing but the work done per cycle. It is nothing but the work done per cycle. So this we can say area 1, 2, 3, 4 is giving the work done per cycle. So this area is giving you the work done per cycle. So now we can convert this 1, 2, 3, 4 in we can create the same we can. So here what we are doing, we are taking the mean pressure. So what we will do, we will take the mean pressure. So we have already discussed whatever the mean pressure we are getting in the expansion process, that we are calling as the mean effective pressure. That is, we are calling as a mean effective pressure. So here this is we are concerning with the indicated power. So this is the indicated mean effective pressure. This will be indicated mean effective pressure. So if I am considering mean effective pressure, so if I am taking this is the P MEP. So I MEP means indicated mean effective pressure. So we can convert area A to 1, 2, 3, 4 into ABCD. This area. So this area ABCD is equivalent to area 1, 2, 3, 4, and the length of this. So we can say that this is a PV diagram. It is drawn by the indicator diagram. So we can say this is the length of the indicator diagram. We can say this is the length of the indicator diagram, and this is the, we can say this is the height of the indicator diagram. So we can say that from this we can say that the work done per cycle is nothing but the length into h, length into height. So we can say that, so length is nothing but the swept volume, it is nothing but the swept volume. So we can say that Vs into, and height of this area is nothing but the indicated mean effective pressure, indicated mean effective pressure. So if we can say MEP, indicated. So we can say that that is a PM. So I can say PM, mean effective pressure. So I have taken that is as a PM. So work done per cycle, we got work done, we got work done per cycle is equal to Vs into mean effective pressure, mean effective pressure. Now so Vs is the swept volume, and we can write it in terms of, length of stroke, we can, and area of the piston. So if you are taking, this is the area of the piston and this is the length of stroke, so Vs is, we can write down, so this is the bore dia. So we can find out piston area and this is the length. So if you are multiplying this piston area into length of stroke length, so we will get the swept volume. So we can say that Vs is equal to, we can say this is the, I am taking mean effective pressure initially, then area, then stroke length and piston area. So this is for one cycle. So this equation is for one cycle. So this is for one cycle. It is for one cycle. It is for one cycle. So it is for one cycle. So for one cycle we got the work done per cycle is equal to mean effective pressure into stroke length into piston area. So this equation is for work done per cycle, is so we can multiply with the number of cycles, so we will get the work done for n number of cycle work done for, so we can write down work done for n number of working stroke, working stroke. So that will be mean effective pressure into stroke length into area into n number of working stroke. And this is for single cylinder, this is for single cylinder, one cylinder, or single cylinder one. So if you are finding out work done for n number of working stroke and k number of k number of cylinder, so we can get work done is equal to mean effective pressure into stroke length into piston area into number of working stroke into k number of cylinder, and we know that n will vary depending on the two stroke cycle engine or four stroke cycle engine. So n will be n is equal to n for, this is the revolution per minute, n. So number of working stroke is equal to revolution per minute for two stroke engine, and n is equal to rpm divided by 2, means n divided by 2 for four stroke engine. So therefore this equation will change. Work done is equal to pm l a n k divided by, so if you are finding out this n is in rpm, so we'll convert it into second, so we have to divide by 60, so we have to again divide it by 1000 so that we can convert, because this is in watt, you will get the unit will be in watt. So if you have to convert this watt unit into kilowatt unit, so multiply by division by 1000, so you will get the kilowatt. So this is the expression for indicated power. So this work done is nothing but the indicated power, and this is the formula for indicated power, and that is equal to pm into l stroke length into piston area into revolution per minute n, and into k number of cylinder divided by 60 into 1000, and unit will be kilowatt. This is for two stroke engine. In case of four stroke engine, you will be here n will be converted into n by 2, and how you can find out the mean effective pressure, indicated power, you can find out with the help of this formula. So we'll stop here, and you have to use these are the basic formula, and this formula we are using for calculating the some of the basic problem of IC engine. So we are going to take that problem. So prior to that, you may have understand this formula, how we have derived this formula with the help of indicator diagram, and again for calculating brake power we are using some different dynamometers. So with the help of that dynamometers we are calculating the brake power, and with the help of that dynamometer we can easily find out the brake power of the engine, and with the help of that brake power we can calculate with. So you can see that by using dynamometer we can calculate the brake power, and by calculating brake power for at different load condition we can calculate the indicated power by experimentally. So this now in today's lecture we have calculated the indicated power with the help of indicator diagram. Again we have to understand and discuss how we can calculate the indicator diagram with the help of MOS test and motoring test, that we are going to do in next lecture. Thank you.